Good evening, everybody. Today we're going to talk a little bit about vectors and just do a review of the different concepts that we have. So we started with two vectors. Now these two vectors happen to be in a plane. So the question is, how do I know they're in a plane? Well, the reason I know is because there's only two coordinates. If there were three coordinates, all right, they would be in a three-dimensional area. Right now it's just two-dimensional. All right, so they would be three-dimensional and in space. All right, so in order to get the vector from these coordinates, you do final minus initial. So -2 minus 3 and 5 minus -7. When I do -2 minus 3, I get -5. When I do 5 minus -7, I get 12. And there is my position vector. Now the question is, next thing we did was magnitude. How do I get the magnitude? Well, I'm going to put my square root. I'm going to take my components. I'm going to square them. And I'm going to add them. All right, and when I square them and add them, I take the square root. My final answer should be 13. Okay, so after that, we talked about some vector operations. So here I have two vectors. I want to know how to do 1/2 of v. Well, I take 1/2 and I multiply it times -2 and 5. And it's going to equal -1, comma, 5/2, and there is my new vector. All right, for u minus v, I'm going to take the component from w minus v. I'm going to take the component from w, subtract it from the corresponding component from v. All right, so I have 3 minus -2, and I have 4 minus 5. I did them in that order because it's w minus v, and my final answer should be 5, -1. All right, so for w plus 2, or v plus 2w, you should do -2, 5, plus, and I'm going to multiply w times 2, 6, 8. And when I add the corresponding components together, you should wind up with 4, 13. All right. Now we're going to move to vectors in space. The reason I know that these are vectors in space is because there are three components. So if I want to find the vector between these 2 points, right, I do final minus initial. So why don't you pause the video, do final minus initial, and we'll talk about it on the back end. All right. So if we're going to find vector PQ, that's going to equal what? Well, I have 0 minus -2 is +2. I have -4 minus 3 more is -7. And I have 4 minus 1, which is 3. And notice that this says I want to find the unit vector. So what do I need in order to find the unit vector? I need the magnitude. All right, so I'm going to get the magnitude of PQ. And again, I'm going to set up my square root. Take each component and square it. Square them, add them, square root them. -7 squared plus 3 squared. And when you do out the math, it should be the square root of 62. So now to get my unit vector, it's going to equal PQ over the magnitude of PQ. So that's 1 over 62, or square root of 62, times 2 -7, 3. And you could leave it like that. Some people will distribute, some will even, excuse me, some will even rationalize the denominator. I'm okay if you left it like that. All right, let's take a look at the next one. All right, so the next one says, vector W starts at point P and ends at point Q. Which vector is parallel to vector W? Well, in order to figure that out, the first thing we need to know is, what is vector W? All right, and in order to know what vector W is, we've got to do our final minus initial once again. So we do -4 minus 2. We do 7 minus -1. And we do 5 minus 3. All right. And when it's all said and done, W is going to equal 682. Or excuse me, -6, 8, and 2. Now, in order to find the vector that's parallel, we have to see which vector is a scalar multiple. So if I take W and I multiply it times -1/2, right? -1/2 will give me vector U. So we could say that vector U is parallel to vector W. All right. So we did some vector operations. We did addition and subtraction. However, there are two operations that get us to multiplication. All right, and they are the dot product. Okay, so I have 4 vectors here. I want to know u dot z, I want to know w dot v, and I want to know u dot w. All right. So how do you do the dot product? You take the corresponding components and you multiply them together. All right? As you're multiplying together, you're adding. The result of a dot product is a scalar. All right? So you'll get a single number. So I'm going to change color real quick. All right, so u dot z, I'm going to do 3 times -4 plus -1 times 0 plus 2 times 2, which is 4. So 3 times -4 is -12, plus 4 is -8. All right, so then if I want w dot v, all right, so I do 1 times -4 is -4, and I do -1 times 0 is 0, and I do -2 times +2 is -4, so that again would be -8. All right, and if I wanted to do u dot w, all right, I do 3 times 1, which is 3, negative 1 times negative 1 is positive 1. And then I do negative 2 times positive 2 is negative 4, which equals 0. All right. So what happens? What's unique about doing a dot product and getting 0? Well, if you do a dot product and get 0, you know that the two vectors are orthogonal. And if they're orthogonal, orthogonal is another word for perpendicular. All right, so we're on to the next problem. We're going to talk about finding the projection of U onto V. Now, this is an application of the dot product. And we're not necessarily going to talk about the application, just more about how to do it. All right. So if we're going to do the dot product of U dot V, and then we'll do the magnitude of V and square it. So let's do the dot product of U dot V. So if I have 3 times 7, I'm going to add that to negative 5 times 1. I'm going to add that to negative 4, 2 times 2. So 3 times 7 is 21, plus negative 5, plus negative 4. And that winds up being 12. And if I do the magnitude of V and square it, right, that's going to be the square root of 7 squared plus 1 squared plus 2 plus negative 2 squared. And that should be 54 because I did the square, right? And I squared this whole thing. All right, so my final answer should wind up being 12 over 54 times my vector, which would be vector V, U onto V. So it times 7i plus j minus 2k. All right. All right, so now we are going to talk about how to do a cross product. A cross product is yet another way indeed to do vector multiplication. So we're not going to talk about how to do it necessarily. I'm just going to help you set it up. All right, because this is review. So if I want to do U cross V, all right, the way I start is, and I'm going to start with I, J, and K, and then I got my U is going to be 1, negative 2, 1, and my V is going to be 3, 1, negative 2. All right, and then you're going to set up your determinants. All right. And when you set up your determinants and actually do your cross product, your final answer should be 3i plus 5j plus 7k. Now, the good part about some of the properties of the cross product is you don't necessarily have to do the cross product again. If you've already done U cross V, then V cross U is just going to be negative 1 times 3i plus 5j plus 7k, which basically means you can change all the signs. And as well, if you do V cross V, again, we don't need to do the cross product. You can do it if you want to, but we know that it is indeed going to equal 0. All right. Now the key with the cross product is that you're finding a vector orthogonal to both vectors. So for example, 3i plus 5j plus 7k is orthogonal to both u and to v. So if I were to change the question to this one, which says find a unit vector orthogonal to both u and v, how are you going to start that? Well, you're going to start by doing the cross product. So you're going to start by doing u cross v. And again, I'll help you set that up. So that's I, j, and k. And 1, -4, 1. And v, I have 2 for the I, 3 for the j, and there's no k's. So I put 0. All right, when you get your determinants and do your thing, it should wind up equaling -3i plus 2j plus 11k. Now, how do I make that into a unit vector, you may ask? That's a good question. Once again, we need the magnitude. We need the magnitude of u cross v. And if you square them, add them, square root them, why don't you pause the video and see what you get. Okay, well, hopefully you did u cross v and you did your magnitude. So your magnitude should wind up being the square root of 134. So you do 1 over the square root of 134 times your vector -3i plus 2j plus 11k. All right. Now we have some interesting problems here. Find the volume of the parallelepiped having those three as adjacent edges. All right. Now I've already provided you with the formula. All right. So you can do this one of two ways. You can either do it as two operations. You could do the cross product, then the dot product, or you could set it up as a 3x3 determinant. I'm going to help you set up the determinant. So 3, -5, 1, 0, 2, -2, and 3, 1, 1. If you broke those up into the smaller determinants, which we can do, why don't you pause the video and try it on your own, and then we'll see what we get. All right, well, hopefully you started this. So our 3 determinant is going to be 2, -2, 1, 1. Right? I have a positive on the front of that, so negative goes here. And then my -5 determinant would be 0, -2, 3, 1. Then I'm going to add my 1 determinant, which is going to be 0, 2, 3, 1. All right? Now that I have you everything set up, why don't you do your determinants and see what number you get. Remember, this is a volume, so it's got to be positive. So if it's negative, you take the absolute value, and if it's positive, you just leave it alone, but it will be a single number. So why don't you pause the video, work it out, and we'll see what we get. All right, well, hopefully you paused the video, you worked it out, and we're going to get 36. You did not get 36. Go back and let's start double checking our work. All right, so let's scroll down a little bit. All right, so some of the last things we've done was talk about some parametric equations. So I want to find the set of parametric equations that passes through the points 2, negative 2, 1, 0, and 1, 3, 5. Well, I need two things. I need a vector and a point. Well, I already have 2 points, so I can use either one. But I do need a vector. So what I can do is I can find the position vector PQ. Why don't you go ahead and pause the video at this point. Find PQ. When you come back, I'll give you the answer. All right, so PQ is going to wind up being 3, 2, and 5. And those are our direction numbers. Right, A, B, and C. And I'm going to use those as well as I'm going to use a point. And I'm going to use the point P. So I'm going to use point P as negative 2, 1, 0. Mostly because I think P is just a little bit easier. All right, and I'm going to put them into A, T equals B, T plus Y naught, and Z equals C, T plus Z naught. So why don't you pause the video, make your substitutions, and I will write the answer on the back end. All right, so my X is going to be X equals 3t minus 2, y equals 2t plus 1, and z equals just plain old 5t. And those are your parametric equations that make that line in space. Last problem I have is find the equation of a plane in general form. All right, so for this, I need 2 vectors. So I'm going to look for vector, PQ and PR. All right, so why don't you guys pause the video. Again, I'm not going to make the vectors for you at this point, but I will tell you the answers on the back end. All right, so I did vector PQ and vector PR. I get negative 1, 3, and 0. And I get vector negative 4, negative 1, and 3. Now, in order to get my normal vector, which is really what I need to do PQ cross PR. We've already reviewed the cross product. So why don't you do the cross product of these 2 vectors, and we'll see what we get. All right, hopefully you pause the recording to do your cross product. Your normal vector, which is going to be orthogonal to both, should wind up being 9i plus 3j plus 13k. And again, that is your A, B, and C, your direction numbers. Now you are going to plug those direction numbers along with a point. I'm going to use the point 1. Why? Because I find using ones very easy to work with. So I'm going to plug it into a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. And this is standard form for the equation of a plane. So when I make my substitutions, I get 9 times x minus 2 plus 3 times y minus 1 plus 13 times z minus 1 equals 0. And I'm going to let you pause the video, do the algebra. I'll give you the answer on the back end. All right, hopefully you paused the video and worked out the algebra. Your final answer should read 9x plus 3y plus 13z equals 34. All right, so there are other things that we have done during the semester, but these are the ones that we're reviewing now. Hopefully this helps, and I'll see you next time. Thank you.